Hello, this is Bryant Myers, author of PEMF, The Fifth Element of Health, and I am super excited about this video series because we are going to review electrodynamics, or electricity, magnetism, and light, which really is the foundational physics that you need to understand PEMF therapy and most energy medicine devices. Electricity and magnetism is all around us. We have electric lights and many electric appliances in our house. We have radio, stereo, speakers, CD players. We have cell phones, iPad, laptop, and desktop computers. We have Wi-Fi, Bluetooth, smart TVs, and smart meters. Light itself is an electromagnetic phenomena, as radio waves are too. The colors of the rainbow in the blue sky are there because of electricity and magnetism. Cars, planes, trains run because of electricity and magnetism. Horses need electricity because muscle contractions require electricity. Lightning and the Earth's Schumann resonance and magnetic fields of the Earth are a result of electromagnetism. Energy medicine devices like PEMF therapy, lasers, LED, red light therapy, saunas, Rife machines, scanners, ionizers, TEND units, etc., all is based on electromagnetism. Your nervous system is driven by electricity. Atoms, molecules, all cell reactions exist because of electricity and magnetism. You could not see without electricity. Your heart could not beat without electricity. You could not even think without electricity, though some people, even with electricity, have a problem with that. To understand the basic science of PEMF and to expose the bad science that's running rampant in the PEMF community, we need a solid understanding, for starters, of classical electrodynamics. Classical in the sense that we're not going to get into quantum mechanics yet. Understanding the electromagnetic force starts with understanding what force is. Now, force, in its simplest definition, is a push or a pull on an object. And this pushing or pulling can be both contact or non-contact, as we'll see. Forces are important because they are responsible for changes in motion. In fact, Isaac Newton describes this in his first law. The law of inertia states that an object continues in a state of rest or constant motion unless it is acted on by an outside force. So, for example, your dog sleeping on the couch isn't likely to move unless you apply a force by poking or pushing him, to use a humorous example. Now, forces can be a result of a direct contact, like you're actually pushing or pulling something. It could be an applied spring, it can be friction, drag, tension. Take a look at this image here, you can see a few examples. Or forces can also be non-contact, like gravity and the electromagnetic force. So we're going to mainly be dealing with non-contact forces in this module. And the electromagnetic force we're going to put in terms of a field formalism, such that it is the field that's going to act as the force. You can think of force as an interaction, and there are four fundamental forces or interactions in nature. So as we mentioned, the gravitational force and the electromagnetic force, and there's also the strong and weak force. The strong force takes place within the nucleus of an atom, and it works at only short distances, and the weak force is responsible for radioactive decay and making the sun shine. But in general, the two main forces that we deal with on a day-to-day basis are the gravitational force and the electromagnetic force. Now, where there is force, there is energy. And energy, by a standard definition, is the ability of a force to do work. And there are different kinds of energy corresponding to the different forces. And there are two main types of energy: kinetic energy, which is energy of motion or movement, and potential energy, which is energy that is stored. Energy comes in different forms, as is shown in this chart here. Most energy medicine devices, as I've circled here, are electromagnetic in nature, so we're going to focus on those three main types of electromagnetic energy in this module: electrical energy, magnetic energy, and light energy. Though all are connected within one electromagnetic force, they are all different in their properties and healing power, as we'll see in this whole course. Particles and waves. Classical or Newtonian physics divides the physical world into particles and waves. Particles transport energy and momentum with their mass and motion from one point to another in space. Waves transport energy from one place to another without mass And waves use frequency, resonance, and amplitude to transmit energy. And this is the main form of energy transfer for PEMF devices and most energy medicine devices. Because most energy medicine devices like PEMF use time-varying electric or magnetic fields or electromagnetic waves like radio, infrared, light, and UV, which are more wave-like than field-based, let's begin with a basic understanding of what waves are. So a classical wave theory, which is a good starting point for understanding energy medicine. All life is oscillating or in vibration. Light is vibration. Seeing, hearing, touching, smelling, tasting is all vibration. Oscillations or vibrations are more technically called waves in science. A wave is a generic term for a pattern that repeats itself over time. Sound waves, brain waves, water waves in a pond, ocean waves, light waves, magnetic waves are all repeating patterns. One cycle of a wave is the portion of the wave that repeats itself. So let's briefly define some wave characteristics, as this is really important to understanding PEMF therapy. The first is amplitude or intensity. That's the maximum amount of a disturbance during a wave cycle. So the amplitude is the height of the wave. And classically, the amplitude relates to the energy in the wave, or the amplitude squared, to be more technical. So the greater the amplitude, the more energy the wave has, kind of like loudness or brightness. Those are two examples of amplitude. We'll talk about amplitude or intensity with regards to PEMF devices and what is the best amplitude or intensity to work with. And as we'll see, it's more of the lower intensity or lower amplitude. You can think of amplitude as kind of like just a volume switch. You're just turning up the volume or you're turning it down. The next two characteristics of a wave are wavelength and frequency, which are both related. Wavelength is the distance between two consecutive crests or peaks of a periodic wave, which is a wave that repeats itself. The distance equal to the wavelength makes one cycle of change. So wavelength is the length of the wave. Frequency is the number of cycles per unit time of a wave that repeats itself at a given point. The frequency, which is measured in hertz, is named after the physicist Heinrich Hertz and equals the number of times the signal repeats itself in 1 second, that is, cycles per second. So for example, our ears perceive high frequency as a high pitch or a high note. Now our eyes can only see a very narrow bandwidth of frequencies of the electromagnetic spectrum from red to violet. But violet would be the higher frequency and red would be a lower frequency. So this is the range of frequencies that our eyes perceive. Now in my book and many articles and videos, I give a good case for that. The ideal frequencies for a PEMF device should be 0 to 50 hertz because those are the frequencies the Earth is giving us. Those are the frequencies the cells primarily respond to. Those are the frequencies that have been proven in research literature to work on healing and regeneration of different tissues. And interestingly, those are the frequencies that our brain operates at, and even the frequencies that we radiate according to squid magnetometers. So frequency is very, very important because to transmit energy from one point to another with waves, you need to have the right frequency resonance. Now, besides frequency and amplitude or intensity, the waveform or the shape of the wave is also very important, as you want a rapid rise and fall, as we'll see, like a sawtooth or a square wave. And also the complexity of the pulse train is also very, very important. And that's a little more complicated. We're going to have a whole module where we're going to look at that. We'll come back to electromagnetic waves at the end of this video series and in other modules. But this serves as a simple introduction to the idea of a wave, which is the primary way most energy medicine devices transfer energy from one point to another. Thanks for watching. In the next video, we're going to look at what charge is. It's called electrostatics. We're going to look at Coulomb's law and Gauss's law, what electric fields are, basic ideas of voltage and electrical potential, and all the basic ideas of electrostatics. So we'll see you in the next video.